Imagine watching a cosmic crime scene unfold in real time. Not just through theory or old data, but seeing it as it happens, live, through the lens of one of the most powerful telescopes humanity has ever built. That's exactly what NASA's James Webb Space Telescope did. In one of the most thrilling astronomical observations of our time, it witnessed a star annihilating a planet not millions of years ago but right now, in our time. It's like a front-row seat to the raw power and violence of the universe. And this isn't just some science fiction plot. This is real, unfolding right before our eyes in deep space. The James Webb Space Telescope, also known as JWST, was designed to peer further and clearer into the cosmos than any telescope before it. It was intended to spot the earliest galaxies, unlock mysteries of the Big Bang, and potentially discover planets with life-supporting atmospheres. But no one expected it to catch something so intense, something that seems more like an act of cosmic fury than a simple orbital event. What Webb saw was a star quite literally tearing apart a planet that was unlucky enough to drift too close. This cosmic execution happened in a system several thousand light-years away. The planet, possibly a gas giant or even a super-Earth, was orbiting its star in a very close, tight loop. Too close, it turns out. Because the gravitational forces at play weren't just holding the planet in orbit, they were shredding it apart. This is a phenomenon scientists call tidal disruption. The same kind of force that makes Earth's ocean tides rise and fall was taken to an unimaginable extreme here, as gravity pulled the planet to pieces, atom by atom. The James Webb Telescope didn't just take a snapshot of this destruction, it tracked it over time. Over days and weeks, scientists noticed something shocking. The light coming from this distant star was flickering, dimming, and shifting in ways that couldn't be explained by normal planetary motion. Using its incredible infrared capabilities, JWST detected increasing amounts of heat and dust around the star. This dust wasn't just floating space particles, it was the remains of a planet being obliterated in real time, spread out in a massive arc as it spiraled toward doom. The planet's atmosphere was the first thing to go. As it skimmed dangerously close to the star, solar winds and extreme radiation stripped off its outer gases, creating a glowing tail like a comet. But this wasn't a comet, it was the last breath of a dying world. JWST captured the chemical signatures of vaporized materials like silicates and metals, elements that are usually found deep inside rocky planets. This indicated that the destruction had reached beyond the atmosphere and was tearing into the planet's core. The data wasn't just dramatic, it was scientifically groundbreaking. For the first time ever, astronomers had detailed, time-stamped evidence of a planet being destroyed. Not theorized, not simulated, actually observed. It provided a living laboratory to study how planetary systems evolve and sometimes collapse. It also raised haunting questions. How many planets has our own sun consumed in the distant past? Could this happen to Earth one day? Or to another world that might support life? Scientists believe that this planetary destruction event may also help explain some of the strange signals they've picked up from other star systems. Signals that until now had no clear explanation. Sudden dimming events, flickering infrared emissions, and unexplained chemical trails might all point to similar cataclysmic incidents that had gone unnoticed or misunderstood. Thanks to James Webb, we now know what to look for. It wasn't just the destruction that fascinated scientists, it was the eerie precision of it all. The way the star's gravity disassembled the planet, layer by layer, like peeling an onion. First the atmosphere, then the crust, then the mantle. All this, seen across light-years of space by a telescope that functions like a cosmic time machine. James Webb didn't just show us destruction, it gave us the blueprint of how such destruction unfolds. Even more remarkable, JWST was able to detect how the debris from the ruined planet began forming a kind of disk around the star. This is something scientists have seen before in the form of debris disks around younger stars, thought to be the remnants of collisions. But here they had the rare chance to witness such a disk forming in real time, giving new insights into how some solar systems evolve, how stars interact with planets, and even how future planets might be born from the ashes of destroyed ones. You might be wondering, how close was this planet to the star? Estimates suggest it was skimming the outer edge of what scientists call the Roche limit, the boundary inside which a planet or moon will be pulled apart by a star's tidal forces. It's a delicate cosmic balancing act, and this planet lost. It crossed that invisible line and there was no turning back. Webb caught it right at the tipping point, moments before the final disintegration began. This observation wasn't a fluke. It was the result of JWST's sophisticated targeting system, its ability to focus with insane precision on objects light-years away. The telescope's near-infrared camera NIRCam, and mid-infrared instrument MIRI, worked together to provide both a wide thermal snapshot and pinpoint chemical analysis. This allowed scientists to confirm not just that the planet was being destroyed, but what materials were being stripped away and at what speed. Think of it this way, it's like watching a house burn down, not just in visible light but in every possible wavelength. You could see the smoke, feel the heat, and even analyze the molecular breakdown of every brick. That's what James Webb did for this doomed planet. But perhaps the most unsettling part of this story is how common such destruction might be. Astronomers now suspect that many stars, especially older ones, may be quietly erasing their planetary systems as they age. When stars expand into red giants, they often engulf nearby planets. But this observation showed that even stable stars can pull planets apart if their orbits drift too close, possibly due to gravitational interactions with other planets or rogue celestial bodies. For planetary scientists, this is like finding the Rosetta Stone of destruction. Every data point collected helps decode not only how planets die but how they lived. Their chemical fingerprints reveal the internal structures, histories, and compositions of worlds we'll never physically touch. Through destruction, ironically, we learn more about creation, how planets form, what they're made of, and how their orbits evolve over billions of years. And so, with this one observation, the James Webb Space Telescope didn't just witness a tragedy, it opened a new chapter in exoplanet science. One where endings are just as informative as beginnings. One where destruction is data. And one where the universe continues to reveal its secrets, not in whispers, but in the roaring, fiery death of worlds. Imagine witnessing a cosmic crime scene not through dusty old data or theory but in real time, unfolding moment by moment. Now picture doing that not with the naked eye but through the lens of the most advanced telescope humanity has ever built. That's precisely what happened when NASA's James Webb Space Telescope captured a mind-blowing astronomical event. It didn't see something that occurred millions of years ago, it saw a planet being destroyed by its own star as it happened. A live, cosmic execution caught on camera. It's like getting front-row seats to one of the most violent performances in the universe, completely real, terrifyingly beautiful, and awe-inspiring. The James Webb Space Telescope, often simply called JWST, was designed to go beyond what the Hubble Space Telescope could achieve. It peers deeper into space, further back in time, and in more detail than anything we've ever sent out. Built to uncover the mysteries of the early universe, analyze the atmospheres of exoplanets, and spot distant galaxies, it has already rewritten textbooks. But no one expected it to catch something so violently dramatic. Webb's instruments weren't just gathering pretty pictures of distant stars, they ended up witnessing what looked like an act of cosmic fury, as a star literally ripped apart a nearby planet in a brutal, slow-motion disintegration. This cataclysmic event occurred in a distant planetary system located several thousand light-years away. Astronomers believe the doomed planet may have been a super-Earth or possibly a small gas giant. It orbited its parent star on a path that was dangerously tight. In fact, it was so close that the star's gravitational grip wasn't just holding it in place, it was actively tearing the planet apart. This phenomenon is known as tidal disruption, a process where immense gravitational forces stretch and ultimately disintegrate an object. On Earth, we experience a mild version of this through ocean tides. But out there in the cosmos, it becomes a force of utter devastation. Webb didn't just snap a photo and move on. It studied the system over an extended period, capturing the destruction frame by frame, almost like watching a movie unfold in the vacuum of space. Over the course of days and weeks, scientists noticed something strange. Light from the star began to flicker and dim in a pattern that couldn't be explained by any known orbital behavior. This wasn't just a shadow from a transiting planet. The infrared sensors aboard Webb detected growing amounts of heat and dust around the star. This wasn't ordinary space dust, it was the shattered remains of a planet, being violently pulled apart and dispersed. The first part of the planet to go was its atmosphere. As it drew too close to its star, intense solar radiation and blistering winds began stripping away its outer gaseous layers. This formed a glowing, comet-like tail behind the dying planet, a kind of last gasp before total destruction. But this wasn't some icy space rock on a scenic journey. This was a world in its final moments. Using advanced spectral analysis, JWST detected chemical elements like silicates, iron, and magnesium, materials that suggest the planet's rocky core was being exposed and vaporized. That meant the star had penetrated far past the atmosphere, digging deep into the planet's body. For scientists, this wasn't just a dramatic scene, it was a goldmine of data. For the first time in human history, astronomers weren't looking at theories or computer models of a planet's demise. They were observing it in real time with time-stamped evidence of each stage of destruction. This provided unprecedented insight into how planetary systems live and die. The implications were massive. Could events like this have shaped our own solar system in its early years? Could our sun have devoured smaller planets in the past? And most unsettling of all, could Earth or another habitable world one day meet the same fate? The event also offered potential explanations for previously baffling data from other star systems. Astronomers have long observed stars that suddenly dim or emit strange infrared signals. Some assumed these were caused by dust clouds or comet swarms. But with Webb's new observations, scientists now suspect that many of those mysteries might actually be evidence of planetary destruction. The sudden appearance of certain elements in the infrared spectrum, the flickering of starlight, these could all be warning signs of a planet in its final death throes, a celestial body being unmade by its own sun. What truly stunned researchers wasn't just the act of destruction, but the systematic nature of it. The star's gravity wasn't chaotic or random in how it dismantled the planet. It acted with eerie precision, tearing away the planet layer by layer, like peeling the skin off an onion. First the atmosphere was stripped, then the crust began to disintegrate, followed by the molten mantle. Webb, using its extraordinary sensitivity, managed to pick up these changes in sequence. It was a step-by-step tutorial in planetary death, delivered from light years away by a machine that essentially functions as a cosmic time traveler. Even more astonishing was what came next. As the shattered remains of the planet spiraled closer to the star, they began forming a glowing disk of debris. This wasn't entirely new to astronomers. Similar disks have been observed around young stars and are thought to be leftover from planetary formation. But witnessing one form in real time from an act of destruction was a first. It offered a rare chance to study the evolution of these disks, how they redistribute material, and how the chaotic death of one planet might actually set the stage for new planetary bodies to form from the ashes. Now you might be wondering, just how close was this unfortunate planet to its star? Based on data analysis, scientists believe it was orbiting just outside or right on the Roche limit. This is a theoretical boundary that defines how close a planet or moon can come to a much larger body before being torn apart by tidal forces. Inside this limit, the object will disintegrate. This planet was right at that tipping point. A hair's breadth too far inward and there was no turning back. It was a cosmic gamble and the planet lost. James Webb just happened to catch it during its final, irreversible spiral. This wasn't just a lucky catch. It was made possible by JWST's state-of-the-art targeting and tracking capabilities. With its near-infrared camera NIRCam, and mid-infrared instrument MIRI, the telescope could lock onto faint, distant targets with surgical precision. These instruments worked in tandem, one capturing broad thermal activity and the other providing detailed chemical fingerprints. Scientists were able to measure not just the light but the temperature, composition, and motion of the disintegrating planet. They could even estimate the speed at which its layers were being stripped away. It was like watching a slow-motion autopsy of a world, performed by light alone. Think of it like this: imagine watching a house catch fire. You don't just see the flames, you see the heat in infrared, hear the structure groaning, and watch the walls melt at the molecular level. That's what JWST did for this planet. Every wavelength told a different story. From the flickering optical light to the glowing infrared emissions, every signal added a layer to the narrative. Webb didn't just take pictures, it told a complete story of planetary death, one frame at a time. The kind of data it provided would take decades to simulate and even longer to verify using other means. But what if this event isn't all that rare? That's the chilling thought now facing astronomers. While we used to think of planetary destruction as something limited to the red giant phase of a star's life, this incident suggests otherwise. Even relatively stable stars might erase nearby planets if orbital conditions shift. Such shifts could be triggered by gravitational nudges from other planets, passing stars, or rogue bodies wandering through the system. If our observations are any indication, the universe might be far more volatile than we assumed. Planetary systems may not just evolve, they may cannibalize themselves. For planetary scientists, this moment is a landmark. Every detail gathered from this disaster helps reconstruct the planet's life. What was its atmosphere made of? How thick was its crust? Did it have an iron core? These are questions we can now begin to answer by studying its destruction. Ironically, the disintegration revealed what construction had previously hidden. The death of this world offered clues about its birth. And in that revelation lies the deepest truth of astronomy. Sometimes, the only way to understand something fully is to witness its end. In a single observation, James Webb has rewritten the way we study exoplanets. It showed that destruction isn't just tragic, it's informative. The death of a world may reveal more about planetary evolution than decades of passive observation ever could. It also reminds us of our cosmic fragility. Even the most stable orbits can shift, and even the most robust worlds can fall. But it also shows us how far we've come, how a telescope floating in the void can record the final seconds of a distant planet and teach us something profound. Because in the end, this isn't just about one planet meeting its doom. It's about how the universe writes its stories, not with ink but with gravity, light, and time. The James Webb Space Telescope is helping us read those stories for the first time. And sometimes those stories begin with a bang, but they end with a slow, tragic, and incredibly beautiful unraveling of a world that once was.